Yeah. Is my screen shared with you?
Yes, sir.
Yes.
Okay, good. So basically, this topic is bit complicated for the students. Why? Because this is something new for the students, and this is not yet studied before. Before that, we have gone through DC circuits like series circuits, parallel circuits, resistance, potential difference, EMF, everything. But this is not that much, or this is not the topic which we have gone through first or earlier. So, what do we study in this topic actually? Kirchhoff's law deals with complicated circuits like the circuits in which multiple loops are there, the circuits in which multiple nodes are there, or the circuits in which multiple voltage sources are there in different order, right? So, for that purpose, first of all, I have to tell you that what does it mean by complicated circuit, and what does it mean? I mean, why do we call these circuits as a complicated circuit? So, in this case, complicated circuits means. Oh, sorry. Let me just switch off my camera. Yes, I would be in the writing mode, so I would prefer to switch it off. Okay, so we are here for this. So when I will talk about, I have mentioned few things here. If you see, I mentioned about the node, I have mentioned about the loops. So first of all, I must tell you, or you must know, what does it mean by loop and what does it mean by a node. So simply speaking, nodes and loops are those points from where or at which the current is divided. What happens? At which what happens? The current is divided. So current is divided at a node. So the node is the distribution point. At this, either the current is divided into several currents, or the current is combined back. So I can simply say that node is that point at which current is divided into parts. For example, I is the current which is here, and then it is distributed in I1, I2, sorry, I3, I4, and that stuff in that one, yani in this diagram. And if I say that there is I1, I2, and I3, that is the current which is actually coming from different sources, and that current is now combined together. And when that current is combined together, we can say that is basically junction, I mean, again combined at this node, so it becomes connected, yani it becomes combined together. So Kirchhoffs have two laws. One law, which is law number one, or which is stated as Kirchhoff's current law, KCL, or Kirchhoff's first law. Actually, it is named by this. It is Kirchhoff's first law, right? It is Kirchhoff's first law. Most of the time, you will not get its name as Kirchhoff's current law. You will have its name as Kirchhoff's first law. So when we have Kirchhoff's first law in discussion, it means that all the currents have some algebraic sum, and those all currents would have a sort of combination. So I can say that it deals with the currents at the node, and it is based on the law of conservation of charges. Actually, this is some extensive discussion, but this is asked to you. How does examiner ask you this? That okay, Kirchhoff's current law or Kirchhoff's first law deals with. So Kirchhoff's first law deals with what? Law of conservation of charges. You have to remember that. You have to recall that this law deals with law of conservation of charges. Okay, charge, that is, charge can neither be consumed nor be destroyed at any component. Any charge can be moved from one point to another point, but it is not being consumed. So its statement is important for you, because you are asked about that statement, the algebraic sum of all the currents at any node is equal to 0. That is very, very important, that the algebraic current at all the nodes, yani we consider a single node definitely, but that is equals to all the current entering the node equals to all the current leaving the node. So we have to keep this point in our mind, that if I1 is the current which is entering, and I2 and I3 are leaving the current, so the entering current would be taken as positive and leaving current would be taken as negative. That is why if I apply the statement, then I1 minus I2 minus I3, that is equals to 0. That tells us that algebraic sum of all the currents goes to 0. But if I apply the rule of sum of all the currents, sorry, this is about sum of all the currents. But if I say that sum of all the currents entering equals to leaving, so I can say that I1 is equals to I2 plus I3. Is it? Is this clear to all? So you have to please keep this point with you, that all the currents entering the loop, entering the node equals to all the currents leaving it. ठीक है जी? Will it be clear? Any confusion in that one?
No.
Okay, so here is the other definition. The sum of all entering currents is equal to sum of all leaving currents. So I have a lot of currents here in this loop. So you can just take those currents as negative, which are leaving, and those currents, those currents which are leaving there can be taken as negative, and those currents which are entering, they can be taken as positive. So I4 will be taken as positive, I6 will be taken as positive, I2 will be taken as positive, I1 will be taken as positive, and I3 will be taken as negative, and I5 will be taken as negative. Got it? That is why I have the equation I1 plus I2 plus I4 plus I6 is equal to I3 plus I5. Got it? And if I want to make an equation, I can say I1 plus I2 minus I3 plus I4 minus I5 plus I6, that all goes to 0. Because mathematically, this is what I wanted to, yani what I made here. Is this all clear to you?
Yes.
Then we this second law. This is very important, and there are several rules for this law which we must now how to handle those. So Kirchhoff's current law is actually that law which Kirchhoff voltage law is that law which deals with the potential differences and EMFs. That law deals with potential difference and EMF. So potential difference and EMF means that we can simply say that EMF is a sort of source, property of a source or trait of a source, and potential difference is the trait or property of a load. Potential difference is developed across the load, where EMF is developed or EMF is produced by your voltage source. So I can say that on the base of the law of conservation, yani this law based on the conservation of energy, because you believe this thing that EMF, yani voltage source is the source of electrical energy, and potential difference or load is the is that setup which is used to consume the electrical energy or to convert the electrical energy into something else. So in this way, I can simply say that load is the energy consumer and source is the energy producer. So both of these are just yani linked together with the help of this law, which is your law of conservation of energy. That is why we call it law of conservation of energy, right? So this law states that energy gain per unit. Yeah, this is not the statement for exam, but I would write a statement in the exam statement, that energy gain per unit positive charge from a source. Are you getting my, I mean, words over here? That energy gain per unit charge. So what is actually energy gain per unit charge, isn't it equal to EMF from the source equals to energy loss per unit positive charge across the load. So in the load, energy loss per unit charge is equals to potential difference. So we have to take care of these 2 points, that potential difference and EMF are basically two important characters here. So it works in the loop, and loop is actually that path of the current, or the current in which circuit is completed, and we are going to analyze that circuit from one point to back to that same point. Like if I have started from point A, I will go back to point A. Depending upon my direction, I would consider a loop. So loop is basically that complete path of the current. What is loop? Loop is the complete path of current. Got it? Because in my previous discussion, I told you about the I told you about what? I told you about uh, that node. So node was the point where you were supposed to distribute the current, and loop is that point across which, yeah, around which the voltages and potential difference is distributed. Around which the voltage and potential difference is distributed. So we can simply say that loop is a part of the voltage, EMF, and energy sources are part of this loop. Got it?
Yes, sir.
You are clear? Eh?
जी sir, clear.
Okay. So I can simply say that here is a complete loop starting from A, then B, then C, then D, and back to A. So this way I can say that the loop is either clockwise or anti-clockwise. So when we talk about the clockwise or anti-clockwise loop, it means that is the path in which you are going to follow, or you are going to analyze the circuit. For example, you are coming from A, will reach to B, then C, then D, then A. So it is your choice. You can go back from A to A to D, this is D, D to C, C to B, and so on. It does not make a difference. Just one difference does it make, and that is the direction of, the magnitude of current and direction of the current. Only direction of current, not magnitude of current. I will talk about that. Here, there are some rules. We have to follow the rules uh, for what, to analyze our circuit. And when we are going to analyze our circuit, actually it means that we are having a sort of uh, rules for separately for EMF and separately for your voltage, any potential difference, right? This is what we have to talk about. So first rule is for EMF. So please remember one thing. This is also called sign convention. Remember one thing. I will let you know about the reason, but remember one thing, that if the loop current leaves the positive terminal of the battery, then E will be taken as positive. This is what you will recall it, but what is the reason behind that, I will explain to you. Okay, what you have to recall for your exam, I mean, it would be used in your exam. It would not be asked to you that state the rule number one, state no. You have to know about this rule to apply, or how to apply, and then how to analyze the circuit. So what is rule number one? That is, if the loop current is leaving positive terminal of the battery, that E will be positive, and if the loop current is leaving negative terminal of the battery, that E will be taken as negative. The What is science behind it? Okay, just a second. You are actually, instead of a charge, what you are doing, you are moving instead of a charge. So if a charge is entering from lower potential and it is leaving from the higher potential, will it gain the energy or not? Check this one out. I have made it that in loop current, when the charge is entering from lower potential and it reaches to higher potential, it means there is a gain in energy during this all journey. So that is why we simply make it, or we simply take it positive. Is it clear? Hello, are you there?
Yes, sir.
Okay.
जी सर.
So what we have to think about, or what we have to do, that positive, when a charge is entering from negative terminal and positive, it means it is gaining the energy, and gain in energy will make it positive. And when the charge is entering from negative and leaving the, sorry, entering from positive and leaving the negative, EMF will be taken as negative. Why? Because here the charge is losing the energy. When the energy is lost by the charge, EMF will be taken as negative, and when the energy is gained by the charge, it is the EMF will be taken as positive. Is this clear to all?
Yes sir, clear.
Okay, the next rule, I mean, I will talk about this here with another example, and that example is, here there are several batteries. If you see, there are several sources of EMF I have in this loop, and they are your E1, E2, E3, and so on. Are they? Do you get it? There are several energy loops, and these all yani energy sources, these all energy sources are in different formation. For example, your E1 is here, E2 is here, E3, E4, E5, E6, and E7. There are 7 EMF sources I have put just to make you clear that where EMF will be taken as positive and where EMF will be taken as negative. Okay, I told you that loop is your choice. Loop is your choice. If you want to go from yani clockwise, it's up to you. If you want to go backward, yani anti-clockwise, it's up to you. No worries at all, and nothing is wrong in that. So if I go from A to B and then B to C and C to D, as as it is, yani in this way. So first of all, I would encounter E7, okay, and I'm leaving the negative terminal of E7. So E7 will be taken as negative. Okay. I have made equation here. E7 is negative. Then I'm leaving negative terminal of E6. So E6 would be negative. Then I'm leaving positive terminal of E5. So E5 would be positive. Then I'm leaving negative terminal of E4. So it is negative. Negative terminal of E3, it is negative. Positive terminal of E2, it is positive. And positive terminal of E1, it is positive. So if you are asked to make an equation, usually we are asked to make an equation that is E7, I told you negative, E6, I told you negative, E5, I told you positive. So positive sign is given to that. Then E4 is taken as negative, E3 is taken as negative, E2 is taken as positive. So did you see all signs are awarded here? And then E1 is taken as positive. If you do this all, just make it equal to 0. That's it. Is this clear? So
Yes sir,
if I
clear.
have some values for that, for example, E7 is my 24, 12, 9, 6, 5, 4, and 3. Let's say these are arbitrary values. So this entire combination of the batteries is giving me how much EMF? Minus 31 volt. What does it mean by minus 30 volt? It means the overall impact. This is very, very important. I mean, I want to make it clear to you. What if it would be positive 31, and what if it is negative 31? Okay, positive 31 means that the direction you have selected, the batteries are leading the charges to move in the same direction. Got it? So when your answer will be positive, yani your direction is same as the actual current direction. Got it? And negative means your direction is opposite to the direction of current you have taken, right? Because the batteries are letting the current to flow through in this direction, and you have selected something else, so your direction is opposite to current. Any batteries, let's make it clear over here, all these batteries are connected in such a way that their overall effect is 31 volt, but the direction of the current in the circuit will be here, this way. This is the direction of conventional current. Is this all clear? Negative sign is, yani negative sign shows this thing. Is this clear?
जी सर क्लियर है.
Okay, good. Now there is a rule for loads, and rule for the loads is again having just two considerations. When the potential difference across voltages across the loads will be positive, and when will it be negative. That's it. It is simple game. So here you will say that uh, the EMF will be, sorry, potential difference will be positive if the direction of I mean direction of loop current and conventional current in the circuit are opposite to each other. That is simple, right? That only conventional current is used in these circuits. This is what you have to take care of it. That only what would happen? Only conventional current will be flowing through. Only, right? So conventional current means positive current. So when positive current is flowing through the circuit, it means that we are talking about, or we are dealing with all positive charges. So problem यहाँ से start होता है. Problem starts right from here. If the loop current and conventional current are in the same direction, then what will happen? Then the IR or V will be taken as negative. Yani same direction, current will, yani V will be taken as negative or IR will be taken as negative. This is a rule, you have to take care of it. And the reason behind that is that if you are following the same path in which the charges are flowing, it means you are losing the energy, you are in the favor of, or the charge is set in such a way that it is losing the energy. That is why it is taken as negative. But when the direction of conventional current and your direction are opposite, so conventional current would be set in such a way that it would always suppose, or it will always support to lose the energy. Conventional current, yani charges will lose the energy. But when you are moving opposite to that, it means you are not giving favor to the loss of energy. That is why it is considered as positive. Got it? So please remember this. That is considered as positive. So same direction negative and opposite direction positive. That's it. That's simple. So what is the statement of second law? Statement of second law is, within the loop you will state this word, within the loop sum of EMFs equals to sum of potential differences, or algebraic sum of potential difference and EMFs, algebraic sum of potential differences and EMFs across a closed loop. Here I would add one more word: across a closed loop is always zero. Yani sum of all EMFs will be equal to sum of all potential differences. So if we simply make it here, let's say this is a circuit, and in this circuit I have uh, resistors as well as I have EMF source. So what happens? Uh, yeah, you have E1, E2, E3, E4. These all are 4 are EMF sources, voltage source, and there are loads. 4 loads are there in this circuit. R1 is load number 1, R2 is load number 2, R3 is load number 3, and R4 is load number 4. So they all are in such a way that they are having yani voltage are produced and consumed in the given setup. So let me uh, let me draw the path for that. For example, you will be asked, write the equation, right? Write the equation of by using Kirchhoff's first law or second law. And second thing, what you have to do, you have to calculate the current in this. There are two ways to calculate current in this. One way is just consider all the EMF separately. For example, if I say that E1, sorry, uh, E3, E4, and E2, they all are with the right polarity, and they are just supporting each other. So what would be the total EMF in this circuit? 9 plus 12 plus 24, but this is opposite to them, so it would be -6. So that would be your total EMF available in that one. And current would be definitely flowing through the, our current will be in the direction where the batteries have greater impact. So the batteries conventional current is flowing from positive terminal to the negative terminal. So for this purpose we just select any single reference, the largest, yani the biggest voltage source here. So the biggest voltage source I have is 24 volt. So let's say the conventional current is from positive terminal of 24 volt to the negative terminal of 24 volt. So you will be given by this conventional current. It will be given in the circuit. So you are not supposed to have it. It would be mentioned most of the time. 99% chances are there that conventional current direction will be marked in the circuit. Okay. Now the next is, let's talk about the given stuff. Here is, I have set a loop. A is here, B is here, C is here, and D is here. So the loop is actually clockwise, right? What is loop? Clockwise. Loop mean I am analyzing the current clockwise. So I will enter from A, I will encounter R2. Current is same in this entire loop. So remember one thing, that in one loop, mostly the current remains same in single loop. But if there are multiple loops, then current will be different. But here, because in this question, we have the single loop, that is why it has the same current. So just make it simple in this way. That is, yeah, that is just a second. That is, here it would be IR2, here it is E3, here it is, yeah, I have put all these numbers, sorry for repetition. Dekho, first of all, I mean all these red circles are those in which I have put all the voltage and EMFs. So first of all, IR2, IR2 is taken as positive. Why? Because the direction of black arrow and golden arrow, they are opposite. Yani golden arrow is indicating the direction of loop current, your direction, is it? And direction of this black arrow shows the direction of conventional current. Okay,
Okay.
is it clear to all? So it
Yes,
means
yes.
they are opposite. So when it is opposite, I will take it positive I square R. Now I'm leaving yani I'm leaving the negative terminal of E3. Just see, golden arrow is leaving negative terminal, so E3 is taken as negative. Then I would reach to B. From B to C, I have two components. One is load and the second one is source. So load is R3, and again your direction, yani golden arrow and black arrow, they are opposite, so you have taken it positive. I3 are positive, IR3 positive. Then you are leaving negative terminal of E2, so E2 is taken as negative. Then your R4 is again opposite direction, so it would be positive. Then you are leaving positive terminal of the battery, so it is 6 volt positive, and again opposite, so it is positive IR, and leaving negative terminal of the battery, so it is minus E4. So just make a loop equation for all these. This is equation that positive I2 R2, just excuse me for 1 minute and just see this equation whether you people get it or not. Yes, sorry. Yes. So did you see the equation? Yes. Yeah, and Mohsin,
जी सर।
equation समझ आया?
हाँ जी सर, आ गया।
So this type of equation will be asked to you simply in your exam, that write the equation for this loop or write the equation for this, etc., etc. Okay.
ठीक है सर।
Now this equation can be framed in different ways. देखो, let's say I have written in the form of I2 IR2 minus I3 plus IR3. All the values which were positive, I put them with their respective signs, and then E3 was negative, so E3 is taken as negative, etc., etc. So from here you can separate all E's. Check this one out, from all IRs. So if you will shift them on the other side of equation, there is one problem with the students here, that if they are taking all the values positive and negative respectively, then they have to put the final, any right side of the equation equal to 0. Is it clear?
यस सर।
Yes.
So when you put all the values, you can figure out current. For example, I have made I separated from here, so I is equals to this all and E is together. So you got I is equals to 39 divided by 110, and that makes 0.35 ampere. Here is that point what I explained you earlier. Okay, check this one out, that if current, yani calculated current, our answer is positive, the path of conventional current is correctly selected. Is this clear to you? Yani if you have a positive sign for that, it means the path you have selected was the same as the actual current. But if the answer is If the calculated answer is negative, it means you have selected an opposite path, and the actual current was not in that path. Actual current was in the different way. Got it? Yani different, not opposite way. Is this all clear?
Yes, sir, clear.
Okay. So this was basically related to your uh, Kirchhoff's law. This is another long topic and it needs a lot of discussion. That's why I would not uh, take panga with this step topic right now. Okay. So we will wind it up here, and I will send you a worksheet of Kirchhoff's laws, specifically Kirchhoff's laws. That would be mentioned in the topic. If you have that book, let me open up the book and uh, tell you about that. That